In this video, we are going to be talking about 4 operations we perform in number basis, which are addition, subtraction, multiplication, and division. So let's talk first about addition. As we know, when we perform addition operations, we are used to how to carry over a number when the sum exceeds 10. Our usual additional operations, we work in base 10. So when we work in base 10, it means that when we have two numbers that are having a sum greater than 10 while adding, we usually write the remainder and carry 1 over. For example, if we are to add these two numbers in base 10, we know that 8 plus 3 is 11. We don't just write 11, but instead, we write down the remainder, which is 1, and we carry over that 1. What we have done is simply, we have divided that 11 by 10. And 11 divided by 10 is actually 1, remainder 1. So we've written down the remainder and carried over the divided item. So this is the same operation we perform when adding numbers in other number bases, whereby an addition of two numbers is greater than the base. We are going to divide that number by the base as well. When we solve some examples, this will become clearer. So let's say we have an example 1, and we have to add up two numbers that are in base 5. 24 in base 5 plus 13 in base 5. How do we go about this? 24 plus 13, both in base 5. Now 4 plus 3 is 7. We cannot have 7 in base 5 because the numbers we have in base 5 are 0, 1, 2, 3, and 4. So 7 is not a number in base 5. We are going to divide that 7. We are going to divide it by 5. And when we divide it by 5, we are going to have 1, remainder 2. So what is going to happen is that we are going to write the remainder here instead, and we are going to carry over that 1. So that 1 plus 2 plus 1 gives us 4. So the answer is 42 in base 5. So we want to take note that whenever the sum becomes greater than the base 5, we are going to divide. Now let's take another example of adding two numbers in another base. Let's say we are told to add 35 plus 42, and they are both in base 6. How do you go about this? 5 plus 2 is 7, but you can't have 7 in base 6. So what we are going to do, we are going to divide that 7 by 6. All right? We are always going to divide by the base. So 1, remainder 1. So we are going to take this remainder and place it here. And then we are going to write this number 1 above here. We carry it over to the 10th side. So it becomes 1 plus 3 plus 4, which is 8. But 8 also is bigger than the base. So we are going to divide that 8 by the base 6. So when we divide 8 by 6, we have 1, remainder 2. So we are going to put down our 2 and carry over the 1. If we notice there are no other numbers to add, just this 1. So we are going to bring that 1 down, and the final answer is 121 in base 6. Let us solve another example, this time in base 8. And we have two numbers, 146, adding up with 372, both in base 8. Now, 6 plus 2 in base 8 is 8, but you cannot have 8 in base 8. Just like you cannot write 10. If this was the normal base 10, we can't write 10 here. So we cannot write 8 as well. We are going to divide that 8 by 8, and that gives us 1, remainder 0. So we are going to write down that 0, and the 1, we are going to carry it over to the next side. This becomes 1 plus 4 plus 7. That is 5 plus 7, which is 12. But 12 is bigger than the base. So once again, we are going to divide that 12 by the base. So when we divide 12 by 8, we have 1 remaining 4. We write down the remainder 4, and we carry over the 1 to join these guys. It becomes 1 plus 1 plus 3, which is 5. So the final answer is 540 in base 8. So that's the same process. It's the same process we keep doing. Whenever you are adding, you add it the way you are used to normal addition. But once the total sum, what you've added, is bigger than the base, always divide it. So let's take one more example. This time, let's operate addition in base 16. So if we are to add up, for example, 3AE in base 16 is adding up with 27B also in base 16. Now, if you have watched my previous videos, you will know that in hexadecimal, A stands for 10, E stands for 14, and B stands for 11. All right? If you are confused about this, please check out my previous video on Introduction to Number Bases, where I explained why these numbers are so. Now, E plus B simply means 14 plus 11. So 14 plus 11 is 25, but we cannot have 25 is greater than the base. So we are going to divide by the base, 16. 16 can go into 25 once, remaining a total of 9. So we are going to write the remainder here, 9, and we are going to carry that 1 over. So this becomes 1 plus A plus 7, and A is 10. So this is 1 plus 10 plus 7. That gives a total of 18. 18 is also larger than the base 16. So we are going to divide that 18 by 16. That gives us 1 remainder 2. So we are going to write down the remainder 2 and carry over the 1. This becomes 1 plus 3 plus 2, that's 6. So the addition of these two numbers is 629 in base 16. So the addition of numbers is just your normal addition you know. But whenever that addition becomes greater than the base, you always divide it by the base. And then the remainder is what you are going to write here. You carry over the 1 to the next side. So can you try? Let me give you some examples to solve, and I would like you to drop your answers in the comment section. Let's see if you'll be able to solve these examples as well. Mind you, it's the same pattern which I have followed that you're expected to follow. So just try and add up these numbers. The first one is 3102 in base 4 plus 1033 in base 4. Let me know your answers in the comment section. And the second one is 8764 in base 9 plus 1648 in base 9. Thank you very much for watching this video. Please don't forget to like, share, and also subscribe so you can also get notified when I make other videos.